Good morning. It's a beautiful day on this recording. Let's look at radicals in chapter 18. Radical rules are as follows. The square root of a product is equivalent to the product of the square root of each factor. Likewise, the square root of a quotient is equivalent to the division of the square root of the numerator divided by the square root of the denominator. Okay, so the problem we have is the square root of 45 over 15. Let's break 45 into a product, one of whose factors is a square, 9 times 5. Break that radical into two radicals as a product, square root of 9 times the square root of 5, all over 15. And the square root of 9 we know is 3, so 3 square root of 5 over 15. And fractionally, we can reduce by a factor of 3, so the final answer is the square root of 5 over 5. For our next problem, we have the square root of 54x cubed. The whole idea is to leave no perfect square inside the radical. So we're going to break the radicand into 9 times 6, 9 being a square, and x cubed into x times x squared being a squared. We put all the square factors together, and we put the non-square factors together. Split the radical into two radicals, putting the squares under one and the non-squares under the other. Take the square root of 9x squared, which is just 3x. For our next problem, we're asked to add two radicals. We can only add like things, so we need to extract any perfect square from both radicals to see if we have like radicals. So square root of 27 is equivalent to the square root of 9 times the square root of 3, which becomes 3 square root of 3. Square root of 75 becomes the square root of 25 times the square root of 3, which becomes 5 square root of 3. We now have like radicals, both square roots in the same radicand. So we keep the like radicals, square root of 3, and we add the coefficients, 3 plus 5, so we have 8 square root of 3 as the final answer. For our last problem, we want to take 5 times the square root of 9a to the 7th, b to the 4th. Notice I said times. Between the 5 and the radical is understood to be a multiplication symbol, most important. Now, we can take the square root of 9a to the 6th, b to the 4th. Obviously, 9 is a square. The square root is 3. The way we can take the square root of exponentials, since we're talking square root, if the 2 divides into the exponent exactly, then that quantity is a square. So 2 goes into 6 3 times, so the square root is a cubed. 2 goes into 4 twice, so b to the 4th is a square, so its square root is b squared. And we still have, we're multiplied times square root of a. For our final answer, we multiply the numerical numbers. We get 15a cubed b squared, all times the square root of a.